Good afternoon, everyone. So welcome to our second presentation in the learning series that we started. And this time we are focusing on smart spaces to drive innovation. In the last webinar, we covered some very important topics. We talked about health and safety and how RIZE is pioneering health and safety in educational institutions, industrial and medical applications. We also talked about color and how color will expand the usage from engineering teams to arts, humanities, and bring a whole ecosystem of new users to design thinking and to innovation, take their idea to physical and innovate on top of that. Today, we have two presenters. This is Kishore Boyelakunta. I am Vice President of Products and Marketing here at RIZE, and joining me, Greg, can you introduce yourself to the team?
Thanks, Kishore. This is Greg Donald. I'm heading up our focus on the academic space in North America.
Fantastic. So you will see me and Greg go back and forth while we do this presentation, and towards the end, obviously, we will answer any questions that you have. So let's get started. A quick introduction to RIZE. We are a Boston-based company. Basically, we are in growth stage, and I think we are very proud to say that we have some fantastic customers that are using RIZE to innovate on their products. That includes companies like CONMED, ZF, a company in Detroit called PSMI that manages tool cribs for 200 plus manufacturing floors, universities like Virginia Tech, US Navy, and such. One of the things we want to bring to market, and we are bringing to market, which is unique, is we bring certified printers and certified materials to you. Certified for health and safety with UL Green Guard certification, and our material, the RIZE material that we send to you is actually USP Class 6 certified, and we will talk a little bit more about that during the later part of the presentation. Okay. Just one more slide about RIZE before we talk about the core contents of this learning series. One, at RIZE, we have a patented technology. It's the world's first and only company that has this. It's called augmented polymer deposition, which you see right there. And APD is a combination of two well-proven technologies. It's basically combining material extrusion and ink jetting, and it allows you to do some very, very interesting things. It allows you to create intelligent parts, which enable smart spaces. It allows you to do color that you see down here, and also it allows you to do on the safety as well as some support removal, and we will talk a little bit more about that as we move forward. The other thing is material science and innovation. In 3D printing, a lot of times people start with the printer. Actually, it should be the other way around. You should start with material, because material is what does the applications for you. And so in the next webinar, the third one in this learning series, we are going to talk about, it all starts with materials. So you lead with material science, and that's for the next presentation. But today, we will keep it very brief. RIZE is our material, proprietary material that is safe, that has good strength, as you see here, zero emissions, recyclability, and it's also USP Class 6 certified with zero emissions. We will deep dive into this in the next webinar on this learning series. Okay. Greg?
Thanks, Kishore. So let's dig into our main topic for today, which is all about intelligent parts and smart spaces and innovation. So this 1-minute video is going to show some of the key components of the smart space. What you see here is rapid prototyping equipment, which is our RIZE printer. You see design software. And then you're also going to see an environment that enables interaction. So this is something that many of us are already doing to varying degrees. So you see the printed part coming off the machine, being removed, and then the person in the video is going to be using some unique equipment to view some of these, the physical part in a digital environment. In this case, the QR code is enabling access to a database of information. And you can see here the person using the VR equipment for additional views of, in this case, the human heart. So, smart spaces, we've been talking about them, and I think it's important to jump in with the definition. A smart space is a physical or digital environment in which humans and technology-enabled systems interact in increasingly open, connected, coordinated, and intelligent ecosystems. So one of the key missing elements in the past has been a secure tie between the digital and the physical. In this example, we can see the digital model or twin on the left, you see the beating heart, and then you see that same model on an RIZE printer as it's being built. The final image on the right is your physical model or your physical twin. So this, in a nutshell, is what smart spaces are about. You sure?
Thank you. Thanks, Greg. So basically, what RIZE enables you is to connect in seamless ways without any friction, going from your digital model, which is your idea, very quickly 3D print it, and you have a physical part in hand, and you can actually loop this fast to innovate, okay? So what are smart spaces? Obviously, we have three key areas. One is digital augmentation with Industry 4.0 technologies. Every university and companies we talk to are thinking about Industry 4.0, or either they have implemented it now or thinking about it for the future. And part of Industry 4.0 is to have fully connected digital physical systems, and we will talk a little bit more about that. Generative design is a big part of smart spaces. We do some very interesting things on generative design because of our augmented polymer technologies. And finally, the intelligent part. So these are the three key components of the smart spaces that you can build at your university, at your school, or at your company, and innovate on top of that. So here's an example of this is a gimbal of a drone. And what you are seeing here is you start off with a rough shape, and with generative shape, you can actually come up with the most optimized part for weight, and basically with all the characteristics that you're looking for to mount a camera and such on top of it, okay? And once that is done, you can take that file into RIZE, and in a few clicks, basically go ahead and 3D print the part. One of the unique things about RIZE, as I mentioned earlier, is that we actually combine material extrusion as well as inkjetting. And with the inkjetting, you can print some QR codes. And this is where the part becomes intelligent. And what happens with this QR code is when you scan it, like you see on the picture on the right-hand side, it now goes into the digital ecosystem that you have and brings the part information. Who made it? Which design is this? Because designs evolve quite often. Which drone is it mounted on? So if there is some repair, you can actually print the exact same part and put it back on the drone. You can look at the expiry date. You can look at what material is this printed on. You can also look at, make sure that your IP is protected, because the QR code is embedded deep into the part and you can't just scratch it away. So for the first time, what you have is, with our augmented polymer deposition, you can now connect your physical part to the digital and make a digitally connected 3D printing part, which is smart in some ways. Okay. Now, so let's take a look at how this process works. Okay. So here I'm going to show you how you go from a design to a 3D printed part, how you remove the supports, and how you can leverage the QR codes to get the intelligence on this particular part. You are seeing a design here done in, it could be any CAD system, doesn't matter. Here in this case, you are seeing it in CATIA. And once that is done, you can do some simulation, and based on the simulation, you can optimize the part using generative shape or your own design intuition or whatever that might be. Once it is done, you take this part into our software called One Touch. And here, this is designed with the user in mind and making it very easy for you to go from here to the 3D print. So let's take a look at what's involved. You could actually add, if you're a student, your name. If you're a company, you can add your logo, or you can put your project name. And once you put it, it actually conforms to the geometry and make sure it's on that particular surface. You can also put here QR codes with a lot of intelligence embedded in it, like you see right here. It's printed on the printer and all that other information. You just drag it, drop it to the surface, scale it to the size that you want, and you're done. At this point, you want to center it to the plate, so you hit the center button, and finally you're ready to print. You go to the prepare job, and we automatically create the supports, and we do some very interesting things, which I will talk about later. Here you're seeing our printer. The printer comes with the bed automatically leveled. You put the build plate in, and at this point, it's a very easy to navigate user interface. You go, you can scroll, select the part that you want to print. It tells you that it's ready with all the material that is necessary, and you go hit the print button. The printer has some fantastic material management as well, where you have two spools, and if one spool is over, automatically the second one takes over. So you don't have to worry about the print job stopping in the middle of the part. You can see what's happening now is the printer actually figures out, make sure it's the build plate is level, and once it's confirmed, it goes into the print process. You can also see here, while it's printing, it's actually jetting the ink. So it's putting that RIZE logo that we put on the part right there. And once it is done, you'll be able to see the QR code and everything else on top of the part as well. You see the supports. One of the things we do is we have something called a release ink, and the release ink goes in between the support and the part, and it allows you to remove, just peel away the supports in very easy ways, and we will talk a little bit more. Okay, scrape the part of the bed, and at this point, because we have this release ink, like a mold release agent, you just basically very quickly peel the parts away. And for those hard to reach areas, you can use some tools, and you basically snap it off. Two things happen. Your surfaces are smooth, so you don't have to do much of post work at all, so you get functional surfaces. And finally, as we discussed, here you have an intelligent part or a smart part, however you call it. You just scan the QR code with all the valuable information that goes with it. So now you have seen the printer, you have seen the print process end to end, and you have also seen how we add intelligence to the part with marking and the QR code, and now you have a fully connected physical part to your digital ecosystem. Okay, so what it allows you to do is it allows you to integrate RIZE easily into your existing workflows. One, you get versatility, which means wide range of applications and use cases. It comes with a standard power supply, so you just plug into your wall socket out and you're ready to go. Time to finished part. This really helps minimize bottlenecks. And what we mean by that is that getting the part ready to print is fairly straightforward. You saw that, it's few clicks. Sometimes you might have to get the geometry right so you get your print correctly, but most of the times with minimal preparation, you should be able to print the part. And because we add the release ink with this augmented polymer deposition process, you can very quickly remove the supports, which means the labor to remove supports is quite low. So you have a very fast time to finish part compared to other FEM systems. And you can increase capability with color and augment existing capacity, including USP Class 6 biocompatible materials. Okay. So what are people doing with smart spaces? We see some fantastic things around product innovation. Here's an example of a company, SI2, and what they talk about is an ability to use RIZE 3D printer that you see down here. Uh, um, they're telling us that they're able to do things 6x faster compared to traditional methods, and they're saving close to $2,000 per part. And the easy post-processing is a big deal for them. So what do we do in product innovation with smart spaces? Accelerate time to part with faster iterations, because you have a really fast time to part compared to other FDM systems. Increase product performance and generative shapes with new and lightweight designs that you see right there. We see customers innovating on the manufacturing side as well. And one of the very interesting things we heard about is sending a 3D printed part in color with the drawings for manufacturing. A lot of times, when you manufacture a part, 60% of the time there is an error between the design intent and the manufactured part. Sometimes minor, sometimes major, on the dimensional tolerances, the surface finishes, and such. And you can reduce that. Companies are doing a lot of things around model-based definition, and you add on top of this a 3D printed part to somebody who is manufacturing. It makes understanding the drawings easier, and you can really compress the error rate from 60%, and according to some metrics by the US government, you can get down up to 10%, you're leveraging MBD and the 3D printed part. So it makes much easier and faster design to manufacturing handoff, very low setup time, assembly consolidation, and low cost setup. These are some of the things that we are seeing with 3D printing in the manufacturing side of things. On the service side, we have our customer PSMI that's doing some very interesting things. They talk about something called take one, make one, where if something breaks and it can be replaced with a polymer part, they are able to 3D print it on the factory floor, very quickly get the factory up and running while they get the original parts manufactured and get up to speed. Again, compared to traditional manufacturing, they are seeing some part costs reduce as much as 98%, cut lead times by as much as 8 weeks. And with ink marking capability, you can see here they're branding, they're putting the part numbers right there, and for safe, easy production of industrial parts, providing compliance and plant safety policies. Greg, you want to talk to this?
Yeah, so let me jump in at the start at the very least. So in terms of innovation of smart spaces, this means in an academic environment, the ability to print intelligent student parts applies in the following ways. One of the things that we've seen certainly in commercial space and also in academia is the ability, the need for a better system to track one design iteration from the next, not in the digital, but in the physical world. The ability to actually mark parts means that you have the ability to differentiate one design from another. The other thing is that it's gone to many schools and seen the system by which parts are returned to students. It's generally a bin with the student simply placed together and the students come and collect them. So in this case, you have the ability to actually use a student number if you want to differentiate parts, or a student could even take an old JPEG or headshot and get embedded in the side of the part. Just one other way to actually signal that that part is their own. The other thing is around project submissions. The student could actually use a QR code and embed additional data about that project. Perhaps they could link out to their Google Drive and provide additional information about the process behind that design. There could be assembly instructions, there could be a host of additional information, but rather than just being a simple physical submission, it now has that tie to the digital. Again, specifically about the RIZE capabilities, this does allow for very safe and easy operation by the students and the staff. You do get accurate replications of your designs, as we discussed, the very fast time to part, and then the ability to differentiate one project from another with the different inks. Completing designs faster, it's interesting. The one thing I've seen across many additive labs at schools is that there are quite often shared due dates. And when you have shared due dates, this often means bottlenecks and it's just human nature to wait until the last minute. So being able to have a faster time to part can really help to alleviate that. They also have the ability to take your designs, and as with the part in the video that Kishore walked us through, being able to, you could do an FEA analysis, but then actually have that physical part in your hand is just another additional way to really be able to appreciate those design elements. And the ability as well to create functional parts that you can utilize and to test in an environment. Finally, in terms of reducing printing costs, so one of the things that's really important is the ability to manage the input costs and to manage the post-processing as well. So if you have equipment that's older, you can have replacement parts built. You can do a lot of custom work. I've seen a lot of experiments at schools where they require it's not the part itself, but it's actually brackets and building it. And then just as well being able to have your equipment up and running for a longer period of time. So Kishore, if you have anything else to add, please jump in. Kishore? Oh, okay. And so then let's take a quick moment here and address safety. And so what we're going to be talking about is safety, certainly within the context of the UL Green Guard certification. So we had talked about this before, but just to review, UL is Underwriter Labs. It's a name we've all seen the insignia on equipment we've purchased. It's a trusted name. And what they've been attempting to do is bring some standards to 3D printing with respect to safety. So our RIZE 1 printer is the world's first printer to receive the UL 2904 Green Guard certification. And what that means is that during the operation of the printer, you do not have off-gassing that you need to worry about. You also do not have hazardous chemicals being utilized in either the printing or of your parts. So within an educational environment, what does this mean? What I've been seeing is a lot more activity on the part of environmental health and safety departments. The ability to cite this certification is pretty crucial with them, so you won't have any issues. You also do not have to worry about the additional cost for infrastructure to add ventilation or filtration of the air in the room. You also do not have additional cost for hazardous waste acquisition or disposal. And then ultimately, you also have peace of mind for your own health.
Thanks, Greg. So the next few slides are a repeat from the last presentation. The reason we did it is 80% of the attendees are new in this webinar. So for those who have seen this, just bear with us. We will go through this very quickly. One of the things we do with our RIZE product that you saw early in the video is to print in color. And the world around us is in color, and it opens a whole new realm of possibilities for educational institutions and companies. If you look at the kind of applications, today 3D printing is mostly used in robotics and in schools, mostly used in engineering inside colleges, widely used, I would say. But with color, now you can have architecture, industrial design students, life sciences students, arts and humanities, business and marketing actually leverage color 3D printing to bring new innovations into their thought process. One of the examples is, I'll tell you, is at Babson College, which is a business school here in Boston. They have a whole workshop. It's almost like Fab Lab with all kinds of 3D printers for their MBA and undergrad students, because a lot of them are trying to create new businesses around products and things like that. So you have now, and with 3D printing becoming easy, students who are in business actually coming up with ideas, 3D printing them, prototyping them, and going and doing business pitch to raise capital. So you have all kinds of views, and especially with color, it really broadens the spectrum. And if you are an educator, this is exactly what you want to do. You want different thought processes, innovating, somebody who is in art coming up with a fantastic product design, somebody who is in STEM coming up with a fantastic product design as well. So the color means a lot. And with affordable 3D printers from RIZE, you can actually bring some really new paradigms into your schools, colleges, and universities. Here's an example of this cart we already looked into. Here's a customer of ours that has 3D printed the design to manufactured part and the variance in dimensions to show how much deviations in the part are. So you can do some very interesting things with color for both functional as well as prototyping applications. And the way we do color is with the CMYK ink. So you have 820,000 plus colors that we 3D print. These are vivid with the ease of use for both engineers and non-engineers with complex geometries. You can see that, and you can obviously come up with new applications probably we at RIZE could not even imagine today. Now, traceability and augmentation, this is where the intelligence happens. Some very interesting use cases where we already talked about intelligent part information that comes from scanning the part. You can do augmented reality, virtual reality. What you're seeing here is an e-drawing app from SolidWorks. You can actually scan it and visualize the part in AR, VR for better communication. You can get assembly instructions by scanning the part, and you can also take it to a marketplace where you can 3D print it. And today, these are the four we are able to imagine, and I'm sure with time, there are many more new applications that will come once you add intelligence to the part with QR codes and other ways onto the part. We talked about post-processing. One of the things we do that's unique at RIZE is we jet not only color, we also jet the release ink. And when we jet the release ink between the supports and the parts, you can see how easily the supports are removed right there. And very quickly you have a part in hand faster than traditional approaches to FDM. And here's one example where water soluble or liquid soluble versus RIZE 3D printed parts. There are cases where water soluble applications can do geometries that we cannot, especially with enclosed spaces, certain geometries that RIZE cannot do. But for most applications, you can do it much faster with RIZE than water soluble supports and such. Here's another example where basically you have a fairly large surface where the support can be easily removed. You can see the marking on both sides, and you have a few more, but I'm not going to spend time taking you through all of them. But just shows how our releasing enables faster part in hand. Okay. And we are seeing all kinds of diverse applications from conceptual design all the way to service MRO. You can always, we already talked about this gimbal, which is generative shapes. You can come up with some really cool conceptual ideas and iterate with the design reviews that you are seeing right there. Sometimes design changes are very minute and you can't visually tell one iteration to another, and putting a part number, version number can make a world of a difference. Greg already talked to it. Once you do finite element analysis, you can actually 3D print the part with full finite element results, whether it's displacement or stresses or whatever that might be. We already talked about design to manufacturing handoff. This is where you can 3D print the part with colors, critical surfaces in one color, holes of the same size in a different color, certain surface finishes in certain color. You can put dimensions where appropriate. And now it's a much better communication tool between design to manufacturing handoff. We have customers that are doing quality and inspection. And we have with our carbon composites, you can, for certain applications, you can actually do some very interesting tools, jigs and fixtures. We have seen some end-use parts, and we already talked about service MRO with PSMI as a customer. What this means is it drives innovation, it compresses time to market, and it reduces part cost compared to traditional manufacturing that you already saw before. And I turn it back to Greg.
Thanks, Kishore. We're at 2:30, so I'll move quickly here. So we have two machines, the RIZE one, which we refer to as our monochrome printer, RIZE, which we refer to as our all-in-one with color and composites. Materials are Rizium, which is in white and black, and have our carbon composite material. Our software we call RIZE One Touch. There is a PC version, but we're also working on a version that you can utilize from your phone. And then among our inks, we have the color CMYK inks, we have our marking ink, and then we also have the release ink, which enables the very quick post-processing. So I will remind everybody we have another session that's coming up in the near term. It's going to be focused on, it's really going to be a deeper dive into the science of the materials behind our technology. If you have any questions, please send me an email or give me a phone call, and then you can see some additional information that's available on our website. We are very, very open to thoughts and ideas on additional topics, and I think we can be doing different or better. And I just want to thank everybody for joining us today.
Thanks, Greg. And finally, this is, we are all facing this incredible, unusual situation with coronavirus and COVID-19. At RIZE, we are doing our part, and we want you to collaborate with us. There are many, many challenges, some we understand today, and many that we don't. And if you are seeing something in your community that you think a 3D printed part can help, please reach out to us. You go to our website, it's right there on the main page, you click on it, and we are trying to develop applications for point of care, for pharmaceuticals and medical devices. If you have some ideas, connect with us. We will try to develop the design, we 3D print it, and if applicable, together we can make a big difference to the healthcare workers and the patients that are battling this today. So with that, we are past time, but if you have any questions, I will stay on the line for a couple of minutes. Thank you for joining our second webinar in this learning series. And as Greg mentioned, the next one is about leading with materials. And it's not just RIZE materials. We'll talk about materials in 3D printing, where RIZE fits well. And then we will deep dive into the material properties of RIZE, the certifications, and things like that. Okay. Thank you very much. Stay safe. And please keep in touch if you have any ideas that we can build upon. Thank you.